All right, today we're looking at rate of change and slope, which are really the same thing. You've worked with both of these for a while, especially in Algebra 1. You should have done a whole bunch of this, so you should be pretty good at it. First thing, your average rate of change formula is just your change in y over your change in x. It's also sometimes represented with this delta y over delta x. Delta usually symbolizes change. So there are a couple ways you can do this when you have just a set of values. The way they worked out this example is they did your change in your degrees and your change in your time, which it kind of looks to me like they did that upside down, but that's okay. Looking at this example right here, find the rate of change of each set of data. So you can use the bottom and the top and just compare your changes. Or what I sometimes like to do is just compare the changes like this. How does it change between 26 and 61? That's a change of 35. How does it change between 71 and 61? That's a change of 10. Between 101 and 71 is a change of 30. Between 101 and 151 is a change of 50. So those are all a little bit different, but if you notice over here on your time side, these are also a little bit different. The difference between 7:22 and 7:15 is a change of 7 minutes. The difference between 7:22 and 7:24 is a change of 2 minutes. 7:24 and 7:30 change in 6 minutes. 7:30 and 7:40 is a change in 10. So your rate of change is going to be this change in y divided by the change in x. So if you look at this first one, 35 divided by 7, that's going to be a change of 5 people per minute. If you compared these other ones, these do have a constant rate of change, so they're all the same. 10 divided by 2, 5, 30 divided by 6, also 5, 50 divided by 10, 5. So you can just pick 2 points that are close together, or you can pick the top and the bottom, completely up to you. I'm probably only going to do a couple more of these just to save some time. Looking at this one, I'm just going to do this first one. So the change between 1,220 and 520 is 700 meters. The change in 3 minutes and 8 minutes is 5 minutes. So again, change in y over change in x. 700 divided by 5 is going to be 140. Again, meters per minute. Same thing here, compare the number of vehicles. 2,131 minus 1,610. That's a difference of 521. Between 4 minutes and 11 minutes is a change in 7. 521 divided by 7 is a terrible number if you use a decimal, so leave it as a fraction. 521 over 7 vehicles per minute. That was an ugly example. I wished I hadn't done it. Now, something you do need to pay attention to that hasn't happened so far, all of these y values have been increasing. Your y value could also decrease. Looking here at example number 4, the difference between 4 minutes and 77, actually that one goes up too, my bad. Looking at number 6, the difference between 37.3 meters and 30.2, our distance has gone down. So 37.3 minus 30.2 is a difference of 7.1. But like I said, it's going down 7.1. The difference in your time is 3 seconds. So a negative 7.1 divided by 3 is going to be another terrible decimal. If you reduce the fraction, I'm going to write this one down. 7.1 divided by 3 is a terrible decimal. If you change it, it's just a negative 71 divided by 30. Again, meters per second. Go ahead and flip it to the back of the page. Probably the formula you're more familiar with as far as slope is concerned is this one right here, the y2 minus y1 over x2 minus x1. That's our typical slope formula. You could still use the change in y over change in x. That's exactly what that is, the change in your y values divided by your change in your x values. It doesn't matter how you label your points. as long as whichever one is x1 goes with y1. So for this first example, I'm going to say that this is x1, y1, x2, y2. Your formula, y2 minus y1, that's a 13, over x2 minus x1, 13 minus 7 is 6, 6 minus 4 is 2, 6 over 2 is 3, has a slope of 3. Remember, we also use the letter m to stand for slope. Same thing here on number 2. x1, y1, x2, y2. So 4 minus 4 over 3 minus 6, that's a 0 over negative 3. 0 divided by negative 3 is just a slope of 0. Example number 6. Now when you start having negatives, that's when you really have to be careful. x1, y1, x2, y2. 2 minus a negative 4 divided by negative 13 minus a negative 1. What happens with your minus a negative? Remember, these together, minus a negative, really become a positive. So 2 plus 4 is 6 over, again, double negative becomes a plus. Negative 13 plus 1 is a negative 12. 6 divided by negative 12 reduces to be a negative 1/2. One more example. x1, y1, x2, y2. 3 minus a negative 2 over 7 minus 7. Again, your minus a negative becomes a plus. That's a 5. 7 minus 7 is 0. You cannot divide by 0. This has an undefined slope. All right. Just a little note here. A slope of 0, that's when you have a horizontal line on your graph. That has a slope of 0. It's going up 0 and over however many. Your undefined slope is a vertical line. When you're determining rate of change from the graph, the thing we usually remember here is your rise over run. Okay? How much up and how much over. Okay? Looking at this graph, the easiest thing to do is to first find 2 points where it crosses very well. Crosses perfectly right there. My next point, it crosses perfectly. There might be a few in here, but I'm just going to go ahead and say it's that one right there because there aren't a few in there. Again, rise. I go down 1, 2, 3, 4. That's a negative 4. Run 1, 2, 3, 4, 5. Your slope, rise over run, negative 4 over 5. Same thing on this next one. Find some good points. So it looks like it crosses perfectly right there. And it also crosses perfectly right there. Again, count your rise over run. This goes up 1, 2, 3, 4. And over 1, 2, 3. Rise over run. 4 over 3. Same thing here, looking at this next one. Again, it starts right here, looks like a good point, and maybe not until right here. Well, that one looks pretty good right there, right there. Rise, run, 2, 3, 1 over 3. Maybe just a couple more. Looks like a good point is right here. Sometimes these graphs are really hard to read. That looks like a good one. And this one. Rise, 1, 2, 3, 4. Run, 1, 2, 3. Rise over run. I think that's pretty good. Y'all should be pretty good with this graph. So be sure you can tell the difference between a negative slope and a positive slope. Positive, positive, negative.